Hello guys, today we are going to talk about the polynomial division algorithm. But before we start, I will going to introduce what is polynomials. Polynomial was a mathematical expression made by the sum of variables from degree 0 to degree n with some coefficients. We can write it as this form, where an minus 1, a1, a0 are the coefficients, and the variable x and a variable x and the n is non-negative integers. This polynomial we call it as the degree n polynomials because in these polynomials the greatest power is n. Like you might ask how the polynomial can be divided by another polynomials, and this is actually possible, and this is what we're going to talk about next. First, let's see the division algorithm of integers. When integers a divided by integers b, we can get a quotient q and remainder r. And we can write it as integer a equals to integer b times the quotient q plus the remainder r. And just like integers, polynomial could also undergo a division algorithm. Polynomial 1 divided by polynomial 2, we can get a quotient and remainder as well. And we can also write polynomial 1 equals to quotient times polynomial 2 plus the remainder. But in this case, the quotient and remainder are not necessarily a degree 0 polynomial, which is not necessarily a constant. And this is what we're going to talk about later. So this is how we're going to divide the polynomials. We use the long division method, just like how we divide the integers. But in the integers, we arrange the integers according to their digits. But in polynomials, we cannot do that because polynomials have no digits. Polynomials could only arrange according to the powers, just like x to the power of 3, x to the power of 2, and then x from the biggest to the smallest, which is x to the power of 0. Then we're going to use this for an example, like how we're going to do the long division of polynomials. In this form, we know that 2x cubed minus 3x squared plus 4x plus 5 is divided by x minus 2. So the first thing we need to do is eliminate the largest power terms. So first thing we need to do is x minus 2. See, this is 2 times x cubed, right? So we just let x minus 2 times 2x squared and become 2x cubed minus 4x squared. And then we subtract it and get a leftover. And don't worry, we can just do it again, just like how we do the long division of the integers. So we'll just do subtract, and get the quotients. And finally, if you cannot do it further, and this value or this polynomial will be your remainders. And here it goes to the next part. The remainder Rx after the polynomial division was not compulsory a constant. This means Rx can be any degree of the polynomials, but it has a restriction. So let's see. When polynomial 1 divided by polynomial 2, the degree of the remainder was greater or equals to 0. But it must be smaller than the degree of the polynomial 2. For example, 3x cubed plus 4x squared plus x minus 5 divided by x squared plus x plus 2 is actually equals to 3x plus 1. And this part, you can see the numerator part was the remainder. And this remainder is actually degree 1, which is less than which is less than the degree of x squared plus x plus 2, which is 2. Yeah. And if you say why the degree of the remainder must be lesser than the degree of the polynomial 2, the reason is if the degree of the remainder is greater or equals to the degree of the polynomial 2, which this means can keep on doing the process until the remainder is the degree of the remainder is smaller than this one. Yeah, then this is the reason. So next, when is divisible? If polynomial 1 is divisible by polynomial 2, then we say polynomial 2 is a factor of polynomial 1. Polynomial 1 equals to the quotient times the polynomial 2, which means the remainder is equals to 0. Well, this property is useful. For example, determine whether x squared plus 2 is a factor of x to the power of 4 plus x cubed plus 3x squared plus 2x plus 2. If you find the value of x when x squared plus 2 equals to 0 and plug it into this polynomial and see whether it's 0 or not, it will be much complicated. So instead of this, we can just use the long division method. We just do by step and find whether this remainder is 0 or not. And then you can find if it's 0 and then it's a factor. And if not a 0, then it will left other remainder, which is directly means that it's not a factor of it. Yeah. So the next part we're going to see is why is it useful. In our fields of mathematics, we somehow need to simplify the rational function to a less complex form, which make it more easier to solve. For example, when we want to integrate some rational functions, this is called rational functions. For example, this rational function is in improper form because the degree of the top is greater than the below one, which is the degree of the numerator is greater than the denominator. So if you want to make the degree of numerator smaller than the degree of the denominator, we can do the division algorithm of polynomials. And as you can, and it's just what we say just now, the remainder, the degree of the remainder will always smaller than the polynomials that divides. So we can use this property to find a remainder that degree smaller than this one. Next one. The other application, we can apply the polynomial division algorithm in Euclidean algorithm, um, which we can find the greatest common divisor of of two polynomials. And the process is actually the same like how we find it in integers. Like for example, the greatest common divisor of polynomial 1 and polynomial 2 is equal to the greatest common divisor of polynomial 2 and the remainder. So we can just keep on doing if we cannot find the greatest common divisor, so we can just keep doing the long division, and we finally find that Rx is constant, and then we can stop. Yeah. And then we can find the greatest common divisor. And the below this one is something called the extended Euclidean algorithm. This can be obtained during the long division, and you list out all the equation, and you're doing the back substitution. Yeah. So namely, we can treat the polynomial like an integers. Yeah. So the second one is finding other factors when some roots are known. When the sum roots are known, we can make it as a polynomial like x minus 2, like x minus 3 if the root is 2 or 3. Like this is very useful. For example, if you want to find all factor of the polynomial with degree 4 and you know two roots, and actually you can just simplify the polynomial degree 4 to polynomial degree 2 by also by the long divisions. Yeah. So this is very convenient us to find all the possible factors of a polynomial. And this is all of my topics. Thank you.